Okay, so welcome back to science class, and we were talking about sound. So in our earlier classes we had covered till the reflection of sound, and now we will talk about the range of hearing, applications of ultrasound, and finally the structure of human ear. Before covering the leftover topics, let us cover a small topic which is being left from the reflection of sound, and this is reverberation. You might have observed that a sound created in a big hall will persist by repeated reflections from the walls until it is reduced to a value where it is no longer audible. You might have heard that in halls, when you are in cinema halls or when you are in auditorium halls, whatever the sound given out from speaker, it persists for a while, right? It persists for 1 second or 2 seconds and then it fades away. And this actually happens due to the multiple reflection of sound, or this can be also termed as the persistence of sound or persistence of an echo, right? And what is an echo? It is just the reflection of sound. The repeated reflection that results in the persistence of sound is called reverberation, right? And this phenomena in which sound is getting persisted due to multiple reflections is called reverberation. And to make this multiple reflection of sounds less, or to make the reverberation less, what is done? The roof of walls of the auditorium are covered with sound absorbent materials. And why is it done? Because if the sound persists for more than 1 second or 2 seconds, it might not be good for us to hear the mixing of different sounds, right? One sound is coming at a particular instant and it is mixing with the sound which was there in an earlier instant, right? So mixing of two or more sounds will occur at a particular time due to multiple reflections, and to avoid this, several measures are taken, like the roof and the walls of the auditoriums are covered with sound absorbent materials like compressed fiber board, rough plaster, or draperies, right? These kind of materials are used so that sound can get absorbed, or the vibrations can get absorbed, and they do not continue to persist further. Also, the seat materials are also selected on the basis of their sound absorbing characteristics, right? Because if the seat materials are also sound absorbing, then the echoes can be made less further, right? The echoes will reduce further, and this is how reverberation or the multiple reflections of sound are stopped, to make us hear the sounds clearly without the mixture of different sounds. So by completing this, let us jump into the next topic, which is range of hearing. So I think you know that the audible range of sound for human beings extend from about 20 Hz to 20 kHz. And what do you mean by 20 kHz? 20 kHz actually means 20,000 Hz, right? It is 20,000 Hz. Like in case of grams and kilograms, 1 kilograms means 1000 grams, right? When you have the term kilo, you multiply the normal unit by 1000. So humans can hear sound ranging from 20 Hz frequency to 20 kilohertz frequency, and not beyond that. And the sounds which are lesser than 20 Hz and 20 kilohertz also exist, but we are not able to hear them. Children under the age of 5 and some animals such as dogs, can hear up to 25 kilohertz. And why is this so? Because as a child, as they are beginning their life, their ears are much stronger than a normal human being which has grown up, right? Their ears are much stronger, and therefore they are able to hear sounds of higher frequencies also. But as we grow up or become older, our ears lose their strength or lose their sensitivity energy, right? They lose their energy to grasp those high frequency sounds, and they become less strong. Therefore, we are unable to hear the frequencies above 20 kilohertz, right? As people grow older, their ears become less sensitive to higher frequencies because they become less strong. Sounds of frequencies below 20 Hz or below the lowest range of human hearing, the sounds which are below that range are called as infrasonic sound. And by the word infra, actually what infra means, infra actually comes from the word inferior. And what do you mean by inferior? Inferior means something less than that, right? Something lower to that. So infrasonic sounds are those sounds which are below the lowest level of human hearing, which is 20 Hz. And this it can be also called as infrasound, right? And some examples are rhinoceroses, or there are also some other animals also. There are other animals also. Rhinoceroses communicate using infrasound or of the frequency as low as 5 Hz. Rhinoceroses can communicate using 5 Hz of frequency of sound only, right? So there are animals which can hear sounds below the human range of hearing, right? And these sound levels which are of less frequency are called as infrasonic sound. Frequencies higher than 20 kilohertz are called as ultrasonic sound or ultrasound. You can see frequencies higher than the highest range of human hearing are called ultrasonic sound, right? And by the name ultra only you can understand it is bigger or greater than what we were talking about earlier, right? Ultrasonic sound are the sounds whose frequencies are higher than the highest range of human hearing, which is 20 kilohertz. Ultrasound is used by dolphins and bats for communications also, right? So there are animals which can hear less than the human sound frequency, and there are also animals who can hear more than the highest human hearing frequency, right? And these frequencies are called infrasound and ultrasound respectively. So let us see certain applications of ultrasound. Now ultrasound, as the name only tells you, they have a much greater strength, they have much greater energy. Ultrasounds are high frequency waves, right? They are of greater frequency, more than 20,000 Hz. So they have a very high frequency, and sounds having high frequency have high energy as well. Ultrasounds are able to travel along well-defined paths, even in the presence of obstacles. Even when you block the path of ultrasound, they can pass through it very easily because they have so much energy within them that they can pass through molecular matter. Ultrasounds are used extensively in the industries for medical purposes. As you can see, ultrasound, as they can move through obstacles for a longer range, they can be used for many cases, like to find out flaws in metal blocks. Suppose we have a metal block which has a crack inside it which cannot be seen from outside. Now how will we check whether there is a crack in the metal block? What we do, we pass ultrasound from one end. As you can see, we pass ultrasound from one end. Most of the ultrasound passes through it, but wherever there is a crack or uneven surface, the ultrasound gets reflected from that surface. And if you sense the ultrasound on the other end, the portion where you do not sense the ultrasound, which is this point, the portion where you do not sense the ultrasound, that is the portion inside the block where we have the crack. You can see we have a crack at this portion, so the ultrasound from which is hitting this crack is getting reflected back, and we are not receiving any ultrasound on the other end, right? So here you can see we are using the ultrasound as it can pass through the obstacle very easily, and ultrasound is not able to pass through surfaces which are uneven or surfaces which do not match the characteristics of the earlier one. You can see it was initially passing through the metal, suddenly it found a crack and then it reflected back, and using this we can find out different flaws or cracks in metals. One more important application is ultrasound scanner. Now ultrasound scanner is an instrument which uses ultrasonic waves for getting images of internal organs of human body. Like you might have seen in different pictures, and here is one. What is done? This instrument which is in the hand of the nurse, this instrument is used to send ultrasound into the human body, right? And by the same logic which we have used in finding of the cracks in metals, the ultrasound gets reflected back, and using the reflected rays we can create an image of the internal organs, right? Now internal organs are of different shapes, right? And in some of the portions ultrasound will hit and come back with a greater intensity, and at some other portions it will go hit and come back with a lesser intensity. And using these difference in intensities of the reflected rays, we can find out what is the actual shape and the depth of the given internal organ. So ultrasound scanner, you can see ultrasound can also be used for imaging the internal organs which is inside our body, and this technique is also called ultrasonography. This technique is also called ultrasonography. Ultrasono, this word tells us that we are using ultrasound, and graphy means to find out the picture, right? So using ultrasonography we are actually finding out the picture of our internal organs using the ultrasound. One more application is ultrasound may be employed to break small stones formed in the kidneys into fine grains. These grains later get flushed out with urine. You can see if we have stones in kidneys, if we pass high frequency ultrasound, what it does, it makes this stone vibrate with such a high frequency that the stones break. The stones break into smaller pieces which can easily pass through the ureters, right? And the stones pass out through our urine. These stones pass out through our urine itself. So you can see ultrasound can be also beneficial in getting rid of kidney stones. One very important application of ultrasound which we will learn from now onwards is the sonar. Sonar is a very important application of ultrasound, and sonar has a full form. Sonar is actually a short form. It has a full form: sound, navigation and ranging. You can see the letters used have been highlighted in the same color: sound, navigation and ranging. This is the instrument which uses ultrasound for finding out the depth of the sea or anything which is under the sea level. Sonar is a device that uses ultrasonic waves to measure the distance, direction and the speed of underwater objects. Right? As you can see here, sonar is actually fitted at the base of the ship. You can see water surface is labeled, transmitter and the detector is given here, and here we have shown the seabed, and you can see ultrasonic sound is sent and then received back, and we will see how the sonar works. How does the sonar work? Now sonar sends ultrasound through water, right? Sonar sends ultrasound through water. Then the ultrasound hits the seabed or any other object which is under the water and gets reflected back. The sonar sends ultrasound, it gets reflected by the seabed and comes back, right? The reflected ultrasound is received by the receivers placed under the ship, right? Ultrasound is sent, it reflects back and it's received by the receivers. Then the time gap between the transmitted and the received signals of the ultrasound is used to calculate the depth of the seabed or the object through which it had got reflected. Suppose a fish had been going through the water. The ultrasound might have gotten reflected from the fish, right? Or it might have hit the seabed. So by calculating the time difference between the transmitted wave and the received wave, we can easily find out the depth of the sea. Now here is one more application of ultrasound which we don't use but animals use. Bats actually use sonar. And how? Bats actually create ultrasound. You can see the yellow color lines. Bats create ultrasound which gets reflected from the prey which is moving at night. The ultrasound gets reflected from the prey. The bats receive this reflected sound and they can figure out very easily where their prey is by using these reflected waves. So you can see not only humans, animals also use sonars to for their different uses. So let us come to the next topic, which is the final one, the structure of human ear. So you can see human ear, this is the outer part of the ear which is called pinna. Sound waves is transmitted through the ear hole, right, the hole in our ear, and it hits the eardrum, right. The sound comes, the sound waves or the vibrations come and hit the eardrum, and the eardrum vibrates. And let us see after this what happens inside our ears so that our brain interprets the signals as sound, right. If the ear is damaged, the sound waves cannot go through the ear to our brain, right. That means there must be some connection with the ear and the brain. Something is happening with the nerves here present, the auditory nerves and the ear. There must be some connection. Let us see what is that. So first sound vibrations vibrate the eardrum. Sound vibrations vibrate the eardrum, which is the tympanic membrane. It is also called tympanic membrane, right? And it actually, we are covering the outer ear first, right? The sound is coming through the outer ear and hitting the eardrum or the tympanic membrane. Then the vibrations are amplified by the three bones and sent to cochlea. So after receiving the sound, the eardrum vibrates, and as this hammer, this first bone, ear bone, is attached with the eardrum, if the eardrum vibrates, this bone also must vibrate, right? Because they both are attached to each other. Now if hammer vibrates, anvil which is connected to it must also vibrate, and the small bone stirrup also vibrates. So you can see the vibration of eardrums create vibrations in the bones as well, and this vibration of the stirrup actually sends vibrations to the cochlea. Now cochlea actually consists of different nerve cells floating on a fluid. Cochlea consists of different nerve cells floating on a fluid, and these auditory nerves has endings on the fluid so that they can receive any kind of vibrations occurring on the fluid. So due to the vibrations created by the stirrup, the entire fluid inside the cochlea begins to vibrate, and the auditory nerves receive the vibrations from the fluid of the cochlea. And after the receiving of vibration signals, brain interprets these auditory signals as sound, right? After receiving the sound signals or the vibration signals from the fluid in the cochlea, brain takes up the auditory signals and then it interprets them as sound, and we can understand whatever we are hearing. So this is what happens within our ear, and this happens in a few fractions of a second, right? Whenever I tell you something, you are able to hear it instantly, right? And therefore all these processes, all these 4 steps must be happening in a very, very small time, right? So here we come at the end of the topics sound. So in this class we have learnt about the range of hearing in humans, which is 20 Hz to 20 kilohertz. Then we have learnt about different applications of ultrasound, out of which the most important was the sonar, right? Because it is used to find out the depth of the sea. And actually, for further information, if you want to find out how the sonar works, how they calculate the time gap, you can use the concept of how do we found out the gap for echo, right? We had found the minimum distance to hear an echo, and you can use the same type of calculations to find out the depth of the sea in case of a sonar also. So this is an extra information, you can try it out yourself. Finally, we had learnt about the structure of human ear and how are we able to hear the sounds. So for better understanding of these topics, you can always log into webcoach.com